If we have 0 things, then we have 1 thing. If instead we have 1 thing, then we have 1 thing. We're going to call this thing a block. So in our first case, we have 0 blocks. In our next case, we have 1 block. In our next case, we are going to have 2 blocks. And we're going to say that these 2 blocks are touching each other. What does it mean for 2 blocks to be touching each other? For our purposes, we're going to say that 2 blocks are touching each other if their faces coincide with each other. So this is not touching, and this is not touching. It specifically has to be their faces that coincide in order for them to be touching. Right? And we could have any amount of blocks touching each other. And in this video, we're going to deal with blocks that are all touching each other, but these blocks are only going to go 1 block high. A set of blocks that are all touching each other face to face and go 1 block high is what we call a polyomino. Right? Polyominoes can also be treated as squares, such that the squares, it's a set of squares such that each square is touching another square, or such that all squares are touching each other, right? All connected to each other and touching each other, right? And they're touching each other at their sides. That's essentially the idea. So we have, in this case, 2 blocks that are touching each other and go 1 block high. Now, if we want to determine all possible cases of 2 blocks touching each other and go 1 block high, the way it works is we could take any block, and there are 4 possibilities that we could attach that block to. For instance, if we attach it to here, what's really interesting is that this block pile looks as though it's identical to this block pile, because we see, visually speaking, 2 in a row and 2 in a row. So clearly they're the same thing. But in a way, they're also different from each other, because we see that from this point of view, this block pile is horizontal and this one is vertical. So in a way, they're the same, but in a way, they're also different. Okay, so then what does it mean if I say that these 2 block piles are identical? What I mean by that is there exists a sequence of transformations such that we can map this block pile completely onto this block pile. And when we say transformation, we mean some sequence of rotations, reflections, and or translations. And it turns out what we can do with this block pile is we can rotate it 90 degrees clockwise and translate it so that it completely maps onto this. And that's the reason why this block pile would be identical to this one, right? No matter where we place that other block, you're always going to get a polyomino that is identical to this one. And so there's only one possible case where we have 2 blocks touching each other. One case. What about every case where we have 3 blocks touching each other? Now, this is one instance of a case where we have 3 blocks touching each other. But are there any other instances of where we can have 3 blocks touching each other? Well, it turns out there are. Here's a really interesting property. Every case of where we have 3 blocks touching each other can be determined from a case where we have 2 blocks touching each other. So in other words, we should be able to build off of this case of 2 blocks touching each other to determine every case of where we have 3 blocks touching each other. So if we take that case where we have 2 blocks touching each other, we have 6 possible positions of where we can place that 3rd block. Let's establish a systematic way to determine all cases of 3 blocks touching each other. We're going to start at the top left corner. Well, we have 3 blocks touching each other, and this case is different from this case, which means, well, the reason why they're different is because in this case we don't have 3 in a row, in this case we do have 3 in a row. That's how we know they're different. Right? As a result, we know for a fact that this is its own unique block pile. Right? It is not identical to the one before it. Right? So now let's consider, instead of a block right here, what if it's right here? Well, it turns out you could actually rotate this block pile so that it maps onto this one. If instead, right, we're going to continue moving clockwise. If there's a block right here, we have 3 in a row. Well, we already have a 3 in a row, so this has already been discovered. We're right here. Notice we can rotate it so that it's this case. If it's right here, we can rotate it so that it's this case. Keep going clockwise. If it's here, 3 in a row, 3 in a row, and clockwise again, we're back to the top left, right? We're back to where we started. So as you can see, we have determined every case that consists of these 2 blocks touching each other. In other words, we have determined every case where we have 3 blocks touching each other that was built off of this case of 2 blocks touching each other. And as we stated before, every case of 3 blocks touching each other can be built from this case of 2 blocks touching each other. And therefore, we have determined every possible case of 3 blocks touching each other. There are 2 cases. Right? This is every possible one. What about every case of where we have 4 blocks touching each other? Well, just like before, every case of 4 blocks touching each other can be built from a case of 3 blocks touching each other. So what we're going to do is we are going to determine every case of 4 blocks touching each other by first building off of this case, and then we're going to build off of this case. So starting with the case where we have 3 blocks in a row, right? Again, we're going to establish a systematic way. We're going to start in the top left, and we're going to move clockwise as we venture through this. So starting with this case of 4 blocks touching each other, notice it's not identical to the case before it, right? We see that we don't have 4 in a row here, so it can't possibly be this case. So this is a new case. Okay, so instead of a block right here, what if our block is right here? Again, we don't see 4 in a row, so it can't possibly be this case. But this case is also different from the case before it, because this block pile is symmetrical. This one is not. That's how we know for a fact that this case is different from this case. Right? They can't possibly map onto each other. Okay, so if instead of this we have this, well, it turns out this case can be mapped onto this case by a series of rotations, reflections, and or translations, right? This case is identical to this case. Instead, we have a block right here, 4 in a row, so we've already discovered it. Instead, it's right here. Turns out this case is identical to this case. Instead here, notice this case is identical to the case before it. If our block is here, this case is identical to this case, so we've already discovered it. This case is this case, 4 in a row, we've already discovered it. And we are back to the top left. As you can see, that is every case of 4 blocks touching each other that consists of this case of 3 blocks touching each other. So we have determined every case of 4 blocks touching each other that is built off of this case of 3 blocks touching each other. So we're done working with this case of 3 blocks touching each other. Now we want to determine all cases of 4 blocks touching each other that's built off of this case. Okay, so now that we are dealing with this case now, well, again, we're going to establish a systematic way to discover all possible cases of 4 blocks touching each other. We're going to start at the top left. If our block is right here, notice we have 3 blocks in a row. Right? We have 3 blocks in a row here. Well, we've already discovered every possible case of 4 blocks touching each other that consists of 3 blocks in a row. We've already established every possible case that consists of this. So this case must already exist somewhere previously. If instead our block is right here, notice we do not have 3 blocks in a row. Every other case before this has 3 blocks in a row, at least, and this case does not. So this must be a new case. If instead of being right here, it's right here, notice we have 3 blocks in a row, but we've already determined every case that is built from 3 blocks in a row. So this case we must have already discovered somewhere in the past. If instead of being there, it's right here, notice we do not have 3 blocks in a row. Because we don't have 3 blocks in a row, we know it can't be any one of these 3 cases. Therefore, either this case is identical to this case, or it's its completely new case. Well, notice that this case is symmetrical and this one is not, so they must be distinct. Therefore, this must be a new block pile that we have not yet discovered. So if instead of this we have this one, well, that's 3 blocks in a row, and because we've already discovered all cases with 3 blocks in a row, well, it must exist somewhere that's already exists. So we've already discovered that one. It's right here. Again, we see 3 blocks in a row. We've already uncovered all cases that are built from 3 blocks, so this case must already exist somewhere in the past. If we have a block there instead, turns out it does not consist of 3 blocks in a row, so it can't possibly be one of these 3 cases. Therefore, either this case is equal to this case, or it is its own new case. Well, this case is not symmetrical, so it can't possibly be this case. But this case could be this case. It turns out they are identical, right? It turns out this case is a mirror image of this case. So it turns out, yeah, this case is not a new case. Lastly, we are back to the top left corner, which is where we started. So we have determined all possible instances of 4 blocks touching each other that's built off of this case. So we have determined all block piles of 4 blocks touching each other that consists, or that is, I should say, built off of these 2 cases. But as we stated before, every case of 4 blocks touching each other is built off of these 2 cases, which means we have discovered every case of 4 blocks touching each other, right? And there's a total of 5 cases. Right, so this is basically the idea. We have a really weird pattern going on, though. Like, look at this weird pattern. It goes 1, 1, 1, 2, 5. What do you think the next number in the sequence is? Who even knows, right? It's weird. But nonetheless pretty interesting, right? These are what we call polyominoes, as I mentioned before, right? From the top view, you can look at them as squares. And for our purposes of this course that I'm establishing, this is what we call block pile theory, right? These are basically just piles of blocks, right? Piles of garbage, right? The goal of this course is to analyze beautiful piles of garbage, which we call block piles. What are block piles? And why are they important to our everyday life, right? That one was good. I needed that one to survive. But yeah, that's basically it for this video.